Okay, so we were just asked to determine the identity of 12 unknown solids. So, we were given these 12 solids: calcium carbonate, sodium carbonate, potassium nitrate, iron 3 oxide, iron, graphite, silicon, aluminum, adipic acid, salicylic acid, glycine, and didyl acid. We first were given these 4 solids and told what they were, and we had to test them to figure out the different properties so we could use that to determine what the other solids were. So what I did is I tested solubility of each solid in water, hexane, and alcohol. I tested the melting point by putting it into a aluminum dehydrating dish over some boiling water in a beaker. And if it melted at that point, then it melted at less than 100 degrees Celsius, which is a pretty low melting point. But if it didn't, then I put it into a test tube and put it over a Bunsen burner. And if it melted, then it had a medium to high melting point. I tested the conductivity as both solids and aqueous solutions. But obviously I couldn't test for aqueous solutions if it didn't dissolve in water. I tested the pH of aqueous solutions if it dissolved in water. I tested to see if it reacted with acids or bases, and how. So as we can see, copper 2 sulfate, which we know to be ionic, is soluble in water but not hexane and not alcohol. It dehydrates at less than 100 degrees Celsius, but doesn't quite melt. So that kind of means probably medium to high melting point. It's not conductive as a solid, but it is conductive as an aqueous solution. It has a pH of 4, which is low. And it dissolves in acid, and when put into a base, it turns kind of a milky color, but doesn't quite dissolve. It becomes opaque, you can't really see through it. For the paraffin wax, which is a nonpolar covalent molecule, it doesn't dissolve in anything, it has a very low melting point, and doesn't conduct electricity either as solid. Well, we couldn't test for aqueous as it didn't dissolve, but it doesn't conduct electricity as a solid. We didn't know what the pH was, and it doesn't react with acids or bases. So in general, we kind of figured out that nonpolar covalent things just don't really do anything. Dextrose, which is polar covalent, does dissolve in water and slightly dissolves in hexane, but that was kind of weird. The melting point is, it looks like it begins to melt at less than 100 degrees Celsius and finishes at less than 500 degrees Celsius. So kind of a medium melting point. And it's not conductive at all. And the pH is 4.5, so a little bit higher than the ionic one. It does dissolve in an acid, and it does dissolve into a base. Finally, zinc, which is metallic, is not soluble in anything. It doesn't melt, so a very high melting point. And it's extremely conductive as a solid, but not as an aqueous, but we couldn't test that because we couldn't dissolve it in water. You couldn't test pH, which doesn't dissolve in water, and it doesn't react with acids or bases. So from this, I made a flow chart where we've got if it conducts electricity as a solid, then it's going to be metallic, which I later found out could also work for nonpolar molecular covalent, for network covalent molecules. But this is based off the data that I got here, so I said that only metallic things conduct electricity as solids. If it doesn't, then it's one of these four. So if it does conduct electricity as a solid, and it dissolves in water, then it's either ionic or polar covalent. If it has a lower melting point, then it's probably going to be polar covalent. If it has a higher melting point, then it's probably going to be ionic. Another interesting thing is that if it does have a low melting point and it dissolves in water and it has a lower pH, then it's going to be polar covalent, most likely. If it dissolves in hexane only, then it's probably going to be non-polar molecular covalent. And if it does not dissolve at all, network covalent. So then we tested, we were only given 1, 2, 3, 4, 5, 6, 7, 8 different solids to test out of the 12. But as a class, we put together, I have to sign in. There we go. We put together this chart of data for all the different solids. So for my solid, I got that for number 2, I recorded that it was a white crystal-like substance, kind of like a salt, and that it had a pH of 8.5. I've got a picture of it right here. So as you can see, it's kind of salty looking, grainy, white. And we realized that it was soluble in water, not in hexane, and it doesn't conduct as a solid, and its melting point is medium. Number 5 is shiny, hard, rock-like. Here's a picture of it. It's kind of cool looking, but it's very, very obviously going to be probably metallic. And back to this. The data kind of lines up with that it conducts as a solid, doesn't dissolve in water or hexane. There wasn't a melting point, which means it's probably very high. So that can pretty much be assured that it's a metallic substance, a metallic solid. Number 6 looked like this. Very cool looking, but I got it over my fingers and they were red for a long time. And number 6 had a pH of 5. It was slightly soluble in water, not soluble in hexane, and it was conductive as an aqueous solution but not as a solid, and had a very high melting point. This to me is kind of indicative of it being ionic, but we'll see. Number 8 is a shiny gray powder. Here's a picture of it. Looks kind of like black gray sand, a little shiny, like shaved up pieces of metal maybe. It wasn't soluble in water, wasn't soluble in hexane, and it wasn't soluble it wasn't conductive as a solid, which means that it's probably not metallic, even though it had a high melting point. Number 9 is white crystal-like, kind of like a salt with a pH of 6. Here's a picture of it. It's kind of fun. And it's soluble in hexane. No, sorry, not soluble in hexane. It is soluble in water. And it is conductive as an aqueous solution, but not as a solid. And it's got a medium melting point. Number 10 is a white powder, pH of 2. Let's take a look. There you go. Looks kind of like baking soda. Very, very fine. Kind of got little clumps to it. I recall that one smelled kind of sweet. Oh no, that was number 11. Number 10 is soluble. It's slightly soluble in water, not soluble in hexane, and conducts as an aqueous solution, but not as solid. And it has a medium melting point. And in fact, with this one, it even vaporized when we did it, which was kind of scary and weird. I'm not quite sure if that was supposed to happen, but it did. Maybe we had the Bunsen burner on too hot or something. Number 11, small white beads. Smelled kind of sweet, pH of 11. Let's take a look at what it looks like. Looks kind of like styrofoam almost, but very small, very fine. And number 11 was soluble in water, not soluble in hexane, and it did conduct electricity as an aqueous solution, but not as a solid, and had a high melting point. Finally, number 12, shiny black powder. Number 12 looked like this. This is my favorite one. Looked like very black sand or chopped up Oreos. Very cool. It was not soluble in water, not soluble in hexane, and it did conduct as a solid, but we didn't. And it had a very high melting point, seeing as though we didn't even melt with the Bunsen burner. So that is indicative of it being metallic. So, on that note, here are my conclusions. We've got solid 1, which I did not test, but according to this data set, it's a white powder. We thought it was ionic, doesn't dissolve in water, doesn't conduct as a solid, high melting point. These are all indicative of it being ionic. So, I set that aside as being ionic. Wasn't quite sure. Could have either been calcium carbonate, could have been iron 3 oxide, could have been potassium nitrate, or also could have been sodium carbonate. Wasn't quite sure, but we'll get to why I decided that in a minute. So of the other ionic ones, I decided that number 6 is also ionic, iron 3 oxide. And I chose that one to be iron 3 oxide because if you look at this, number 6 is a red powder. And iron 3 oxide is kind of that's what rust is. And rust is red as well. And so of the ionic ones, 6 was red. So, oops, I decided that one should be iron 3 oxide. Moving on to the next ionic one, we've got potassium nitrate, which is number 9. Number 9. White crystal-like, soluble in water but not hexane, kind of lower than neutral pH, medium melting point, conducts as aqueous but not as solid. Obviously, very indicative of it being ionic. Now, where'd it go? Potassium nitrate has a pH of 6, and we didn't test the pH of number 1, which is kind of a bummer. Should have done that. Finally, the other ionic one is sodium carbonate, number 11. This one had a higher pH. It was conductive as aqueous, not solid, high melting point. Smelled sweet, small white beads, soluble in water. So the pH is what kind of got us to distinguish between these two, this one being sodium carbonate, this one being potassium nitrate, seeing as though sodium carbonate is more basic than potassium nitrate. The only issue here is that we really don't know what the pH of this one is, but the fact that it doesn't dissolve in water is indicative of the fact that it's probably calcium carbonate, which does not dissolve in water necessarily. Oops, where'd it go? There it is. All right, so we got the ionic ones out of the way. Next, we've got solid number 2, which I said was glycine. This one's polar covalent. Let's check it out. White crystal-like, kind of like a salt, dissolves in water, doesn't conduct as a solid, but does as an aqueous, and has a medium melting point, pH of 8.5. So it's basic, but it's got a more medium melting point. And the reason that I said this one was probably polar covalent is because if you look at this flowchart that I made, the polar covalent ones have a lower melting point than the ionic molecules, so I figured since that one had a medium to low melting point versus a high melting point, it's probably more likely to be polar covalent. But I'm not quite sure yet why I decided it was glycine. So, let's move on to the next polar covalent one. Ooh, so this one is interesting. I was stuck for a long time about solid 4 and solid 10, and as to why those ones were polar covalent, and which ones they were. So we know that they're both acidic, which is very common for polar covalent molecules. And I realized that number 4 is soluble in water, whereas number 10 is only slightly soluble in water. And if you look here, I did some research, and salicylic acid is said to have it is poorly soluble in water, 2 grams per liter to 20 degrees Celsius. And then if you go over here to adipic acid is 24 grams per liter at 25 degrees Celsius, which is much, much more soluble in water than salicylic acid is. So therefore, I think that we can safely say that number 4, which is less soluble, is going to be salicylic acid. Take away that question mark because now I know. And number 10, it's going to be adipic acid. All right. So number 5 and number 8, I was a little distraught between whether it was iron or silicon. And in class, we went through a lot of these, but number 4, 10, 5, and 8 were the ones that we never actually quite got to. And I had decided that, so number 5 is network covalent because it doesn't dissolve in anything, it's conductive as a solid, and where's number 8? Oh. So for this one, we did not test the melting point for some reason, which is kind of oh, where am I? Here we go. 7, sorry. No, 5, I'm on 5. No one tested the melting point for this one, which is a bit of an issue. It would have been nice if we had it. But because we don't know the melting point, we went with it as being network covalent versus metallic. And the metallic one having a high melting point. Whereas this one just, we don't know. But the nice thing is it doesn't dissolve in anything, and it is conductive as a solid, but those can both be kind of indicative of it being either network covalent or metallic. So I'm going to say that this one, which is definitely metallic, is going to be iron, because iron is metallic. And this one, which could either be network covalent or metallic, but most likely network covalent, is probably going to be silicon, because silicon is network covalent. So, number 5, that one's silicon. Wait a second, number 5. Yeah. And it's network covalent, not metallic. Network covalent. Yeah. And then number 10, nope, 8. Now that one is going to be iron. And it's going to be metallic, not network covalent. Okay. Number 6, already got there. Number 7, the disyl alcohol. So let's go check that one out. It's a sticky solid, almost like a gel or paste, insoluble in water and floats, low melting point, not conductive as a solid, dissolves in hexane. So the fact that it dissolves in hexane is indicative of it being nonpolar covalent, and the fact that it, that's the only nonpolar covalent out there. So it's got to be the disyl alcohol. Got that one. Number 9, potassium nitrate. We got that one already. Citric acid, got that. Sodium carbonate, got that. Last but not least, graphite. We weren't sure if it was metallic or not, or covalent. However, we were sure that this one was graphite because of the metallic-y network covalent ones. This one rubbed off onto our fingers like a pencil, so we determined that that one was graphite. Oops. So it's important to be able to identify unknown solids because in the science world, because if in a lab you're introduced with a solid of an unknown identity, it's important to know if it's hazardous, if it's safe to be around, safe to use, what its properties are, how it reacts with different things, and just to develop a basic understanding of types of solids. These are my references, acknowledgements. I did use Wikipedia. I'm sorry, but it's very helpful. It knows a lot. All right. Well, that's a wrap.